Hello, I'm Derya and I'm going to talk about Electrospun nanofiber laboratory experiment. Electrospinning is a spinning technique which uses electrostatic force to produce and form ultra-thin fibers. Polymer solution in a syringe is pushed through the needle, which comes out as a liquid droplet and is electrified to form a jet. Positive and negative charge between the needle and collector helps the liquid droplet to form fiber on the collector. Viscoelastic properties of the liquid eliminate the Rayleigh instability, so the jet is continuously formed, it doesn't turn into droplets. The formation of the fibers and their thickness are controlled with electrospinning processing parameters, which are voltage, distance between the tip of the needle and collector, and flow rate of the solution. In this laboratory experiment, polymer solution is successfully added in the syringe pump, nanofibers are produced with electrospinning process, and collected nanofibers are analyzed with tabletop SEM. Polymer solution at a concentration of 28% weight per volume is prepared before the laboratory experiment. 10 ml of the solution is made with 2 g of PANGMA and 9.44 g of DMF. Materials used during the experiments are plastic syringe, plastic pipe and a needle, aluminum foil, pumping device, electrospinning instrument, ethanol and DMF solution for the cleaning. And the parameters for electrospinning are followed as it is seen on the table. PANGMA and DMF with a small magnet are added in a plastic bottle and stirred for 3 hours 35 minutes at 200 rpm. After stirring, solution look completely dissolved. 5 ml of the solution is added in a plastic syringe pump and it was made sure that there was no air bubble in the syringe while adding the solution. Pipe is attached to the syringe with a needle on the tip. Approximately 2 ml of the solution is filled in the pipe and the rest of the solution remained in the syringe. The syringe is placed in the pumping device and pipe is moved into electrospinning instrument. The needle is put in the high voltage hole. It was made sure that the needle is pointing at the collector with an angle of 90 degrees. The collector is already covered with aluminum foil without any wrinkle on it. Cable with charge is attached on the aluminum foil. The distance between the collector and needle is measured as 25 cm and pumping device parameters are set. After setting up the syringe pump and parameters, the door is closed and electrospinning's power cable is attached to the electric socket and the machine is turned on. After turning it on, the voltage is increased slowly to minimize any possible risk. When the voltage has reached 17 kilowatts, spinning started with running the pumping device. Spinning duration was 11 minutes in total. When the spinning was completed, pumping device is stopped and voltage is reduced to 0 kilowatts slowly. After all these steps, the instrument was turned off and the door was opened slightly for air ventilation to absorb all the flying nanofibers. Tabletop SEM is used for analyzing the nanofibers. Small sample is cut from the aluminum foil and put on the metal plate with the help of the double-sided carbon tape. Figure shows that nanomembranes have very fine nanofibers without any pore clogging and unchanged porosity. However, it is seen that nanofiber diameters vary a lot, as it is seen on the pictures. The figure shows formation of the white beads in nanofiber. This could be a result of many different parameters. Viscoelastic properties of the solution, spinning voltage, feed rate, as well as the surface tension can be the reason for the beads. Electrospinning laboratory experiment covered most of the steps of the spinning process and gave a clear idea how it is done and what the challenges are. Challenges occur during the experiment such as air bubbles in the syringe pump, and these challenges helped understanding the process even better. Evaluation of the nanomembrane images done to have better understanding of how fibers and microbeads are formed. Thank you for listening.